So let's try number 10. So just a refresher on our rules, we're trying to eliminate one of the variables that has common coefficients. Right now we don't have that. So we have a choice to make. Do we want to eliminate the x's or the y's? You guys choose.
X.
X, okay. So to eliminate the x's, we have to make these both the same thing. So think about something 3 and 5 both go into 15. So then I would need to multiply the first by something that would get me 15, so 5. And the second by something that would get me 15, so 3. So I'm going to multiply both to change both equations. We have 15x plus 15y equals 45. Remember that the boxes are small, so if you need more space, use the back of the first page or get another sheet of paper. And 15x plus 12y equals 30. And then to eliminate our x's, would we add or subtract the two equations together? So we have 0 plus 3y equals 15. Divide both sides by 3. Once you have y equals 5, then you now have 4 options where to put that back into, the original 2 or either of the ones you just changed. Pick one of them. So let's say I chose the very first one before I changed it. And we're going to put this back in for y. And you're going to solve for x. What is the value of x?
3.
Not 3.
-2.
-2. So that ordered pair would be -2, 5. Is that easier or harder to see from there? Do you have any questions about that process? I'm going to show you how one of the special cases work. I think I said this the last time we were together that 7 is missing in equals. It should be right before the -10. But we could do 7 or 8. I'll let you guys choose.
7.
Sure. So for 7, we have common coefficients. They happen to be both. Both of them are common. Do we want to eliminate x or y? Okay. So if we are eliminating our y's, would we add or subtract? Let's check that. So if I did -4 and I added another -4, that wouldn't eliminate. But if I subtracted them, it would. Remember, if the signs are the same, you subtract no matter what. But what happens when we subtract? You lose the x as well as the y. Everything is 0. So both of your variables disappear, and this would be what type of solution? No solution. So you'll either get 0 equals a different number, or you'll get 0 equals 0. Everything will cancel, or everything will be different. And then it'll either be like this example where you can see that the coefficients are the same or similar, or I think 14, where you may have to multiply one or both, and then they end up canceling. Are there any others you want to see, do, go over, have questions about before I give you some time to practice? You don't have much time, but I'll give you until 9 to practice delta math, missing delta math, substitution, elimination, graphing. Work on those, and then at 9 we will switch gears and start word problems. So you have this time to work up until 9. What's nice about these word problems is we don't have different ways to solve them. We already know how to solve these by graphing, substitution, and elimination. So all the ways that we just learned how to solve systems, we're going to be using those same things. But side note, guys in the back, I said Tuesday, it's Wednesday, because that's the next time I'll see you. That's when your test is. The quiz and test, sorry, I lost my train of thought. On the quiz and on the test, the word problems you're going to have to solve by substitution, elimination. You could practice by graphing, and I could show you how to do that by graphing as well. But on the quiz, on the test, you'll have to do it by substitution and elimination. Also, reminder that just the systems by graphing piece will be no calculator. With all and any word problems, what is the first thing we need to do? Highlight the important details. So we're going to read through, and you can highlight, circle, underline, important details. Jacob and Aiden, go back to your seats. So read this with me. For example 1, a snack bar sells large and small nachos. Large nachos cost $5 and a small pack of nachos costs $3. And one day the snack bar sold 60 packs of nachos for a total of $220. Let L be the number of large nachos and S be the number of small nachos. Write a system of equations to model the situation and determine how many large and small packs of nachos were sold. What's important there?
Large nachos cost $5.
Okay.
Small pack of nachos cost $3.
Okay. What? 60 packs of nachos.
For a total of $220.
Okay. What else?
L is number of large nachos.
Mm-hmm. The number of small nachos. And what are we looking for?
How many large and small packs of nachos were sold?
Right. So after you find all the important information, remember that the question is going to help you define your variables. That would be the next step. Here we already have variables that are defined for us, but to get us in the habit of defining them, whatever the question asks should be what your variables represent. So the number of, how many, and we need to be specific. So number of large packs of nachos, number of small packs of nachos. We can't just put large and small nachos because that doesn't tell us what we don't know about it. Then once we have our variables defined, then we can set up our equations. Anyone want to take a guess as to how we might set up one? totals, which means we're going to be doing what operation? When I add these together, subtract them together, multiply, divide to get a total. Add. Okay, so we're going to add two things together to get 220. What do we think we might add together? Okay, that's part of it. The 5 and 3 will help us get to the 220, but we're missing something.
60.
5L plus 3S. We have to put all that together. Color code is S, so it looks different. So when you have 4 numbers, 3 of them are going to go together in an equation where they're related. So this talking about cost, total, cost, all the numbers are money related, they go together. The last number we have is 60, which is also a total, so we know we're adding. But we can't use those numbers again. What are we adding together to represent the total number of packs of nachos? What else represents number of packs of nachos? Somewhere on here it says number of large packs of nachos. L and S. So anytime you're giving 4 numbers, you're going to add just the variables together. Right. Then you have choices. Once your equations are set up, you can solve by graphing, substitution, elimination. Again, on the quiz, on the test, it'll just be substitution, elimination. Which do we want to see for this? Graphing, substitution, elimination.
Substitution.
Okay. So for substitution, we can solve for L or S because we have to find both. Which one do we want to solve for first? Okay. So if we're solving for L, we have to get rid of S. Whether you put 60 minus S or negative S plus 60, it doesn't really matter here. But then we're going to take that expression and put it back into the other equation where L is. You don't have to draw the arrow, just do it if it helps. And rewrite that. So we have 5 times 60 minus S plus 3S equals 220. And then we can distribute and combine the terms. Combining the terms. And get rid, solve for S. As you're solving right now, because of what we put in solve for, you're going to get a negative. That's okay, as long as you end up with a negative on both sides. So we ended up with a negative on both sides, so that's fine. If you end up with just one negative as you're doing your word problems, that should tell you something's off, something's wrong. How many packs of small nachos do we have? 40. Then we have to go back and find L. And we're going to use this equation that we found, solve. So that L is 20. And make sure you put your labels. So unless the problem specifically asks for just one thing, you should always have two answers. Do we have any questions about that? About the process, defining anything, setting up anything? We're going to skip over example 2 and do example 3. Let's read this one together. For example 3, Christina went to the mall and bought 5 pairs of earrings and 2 pairs of shoes for $30. Each pair of shoes cost $2 more than 4 times the cost of earrings. Let E be the cost of earrings and S be the cost of a pair of shoes. Write and solve a system of equations to model the situation and determine the cost for a pair of shoes and a pair of earrings. What's important there? E and S. E being the cost of earrings, and S being the cost of a pair of shoes.
Each pair of shoes costs 2 more than 4 times the cost of earrings.
That entire sentence. Anything else? $30 is important. Anything else?
2 pairs of shoes.
And we are looking for
The cost for a pair of shoes.
right? Again, our question matches our definition of our variables. The cost of earrings, the cost of shoes. So go ahead and write that down. Cost of earrings, the cost of shoes. One of the equations is going to be set up very much like what we just did. Using that total of $30. How would we set that equation up?
5E plus 2S equals 30.
So anytime you are comparing two different things and you have a total, it's going to be set up like that every time. But this sentence is a little different. Each pair of shoes costs, so it's talking about the shoes, $2 more than 4 times the cost of earrings. So if we knew what the cost of earrings were and we multiplied it by 4 and added 2, we would get the cost of shoes. But how would we set that up? I know it's set it. that equation look like?
E times 4 plus 2.
4e plus 2. So the last problem we did, we had a choice. This one is really set up for substitution, so we're going to do that. While we could rearrange it and solve for elimination, that would be more work than what it's worth. So we're going to take this expression and put it back into S in the other equation. And then start to distribute and solve. What is the cost of earrings? $2. And then we can use that to go back and find the cost of the shoes. Which is what?
10.
10 what?
$10.
Make sure you're putting your units. If you're not sure what that unit is, look back at your definition. Cost of should be in dollars. Any questions on that so far? We're going to do one more of these type, and then we're going to go on to the maze. We're not going to finish the maze today, but we're going to do as many as possible so it gets you in the mindset of setting up, solving in different ways. Go on to example number 4. Start reading that if you haven't already. What is important there? The dimes and quarters part is important because you may get different problems like this, but instead of dimes and quarters, you might get dimes and nickels, or nickels and quarters, pennies, whatever. What else?
5 more quarters and dimes.
That entire sentence. What else? The number of dimes and the number of quarters. And what are we looking for? Alright, so even though they don't give you many numbers here, some of the numbers are assumed. Explain what that means in a second. Let's write our variables. talk about the first one. We have a total of $3.70. How could we write an equation that is going to equal that formula? That will be part of it, but that is just the number of dimes. So if I counted up that I had 10 dimes and 10 quarters, I'm making this up, how could I get to the total cost or worth of 370? Missing numbers in there. How could I add up to 370?
Would it be like 10D plus 25P?
But 0.10D and 0.25. But yes, we need the worth in there. That part's kind of assumed that you got. So 0.10D plus 0.25Q. You don't use the decimal, you get bigger numbers than what you're supposed to have, so be careful there. Alright, so that's going to be one of them, and you would have to know that because it's not going to tell you to add in the worth. The other one, you have 5 more quarters than dimes. So if I knew the amount of dimes and I added 5 to it, I would get the number of quarters. You kind of have to talk that backwards. So this one's set up really well for which method? Graphing, substitution, elimination. Substitution. So that's what we're going to do. Okay. So we're going to substitute that in for Q and then rewrite and solve. Be careful with your decimals. Make sure you're bringing the decimals along. Combine your like terms. And then solve for your variable. What is that? I think it's 45. And then when we divide both sides by 0.35. So if you, let's say, set this up backwards, solve this for D and put Q in here, and then substitute it in, you might get a number that's different, or you may get a decimal. And if you're looking for a number of dimes or quarters, this can't be a decimal. So be mindful of that. And then to find our number of quarters, add 5 to it. So Q is And if we were to put those back in, we should get the 370. Questions on that? So we're going to start the maze. We're not going to get through a lot of it, but you will need another sheet of paper to do your work on. So I would grab extra scrap paper. We're going to start at the first one. Highlight important information, define our variables, solve for whatever is given, and then move on. It will get very repetitive, but we'll be going between the different ways to solve, so that way you're good with all the different ways to solve with your word count. Alright, so at the start, it says, at the movie theater, the Clayton family bought 4 fountain drinks and 3 bags of popcorn and paid $22.50. The Haynes family bought 5 fountain drinks and 2 bags of popcorn and paid $23.75. How much is a pound? What's important there?
4 fountain drinks and 3 bags of popcorn and paid $22.50.
So the 4 fountain drinks, the 3 bags of popcorn, and $22.50. What else?
5 fountain drinks and 2 bags of popcorn, $23.75.
And what are we looking for? Alright, so let's set up our variables first, because the question is asking about how much or the cost of a fountain drink. You know, we need 2 variables. You can call them whatever you want. They can be related to the problem. They can be X and Y. It does not matter. I'm going to use F and P. And this is going to represent the cost of the fountain drink and the cost of the bag of popcorn. In this problem, we are given 6 numbers. All 6 numbers are going to be used. We're comparing 2 different things. What would either equation look like? F plus 3P equals 2250. And then the other one? Now that we have used all 6 numbers, this would be a good elimination problem. We could solve it by substitution, but you're going to have a bunch of fractions. We could solve this by graphing, but again, you'll have not nice fractions. So if we were solving this for solving by elimination, because we want to figure out how much a fountain drink is, we can eliminate the popcorn. That way we don't have to worry about it. So we have to think of a number these both go into. 6. So I can multiply the first by 2 and the second equation by 3. Change both of them. What is that, 45? And I'm doing quick math. Okay. Double check.
Yes.
Thank you. And 3 times 23, 75.
71.
So if we were to eliminate the p's, would we add or subtract these two equations together? Subtract. So let's do that. 8f minus 15f would give us, this would be 0. And then 45 minus 71, 25. Say that one more time, please. Yes. That's okay. I mean, negative.
Negative 26.
Is that what we all got?
No, it's 0.25.
Right? We have negatives on both sides, so we're good so far. Divide both sides by -7. And what is the cost of a fountain drink? $3.75. $3.75. Because we're doing a maze, we can easily check if that wasn't one of the answers given, meaning something was wrong, but it is. So I'm going to highlight that I'm going in that direction, bless you, to show that we're moving on to the box with Ryan. Do you have any questions on that problem before we move on? Alright. Ryan works at the donut shop where he makes $10.25 per hour. He also works part-time at the school bookstore where he makes $8.75 per hour. If he worked 20 total hours last week and made $196, how many hours did he work at the bookstore? So variables, what are we going to call, I'm sorry, skip this up. What's important here?
He makes $10.25 per hour.
I'm going to highlight at the donut shop. What else?
Bookstore, he makes $8.75 per hour.
And then what else?
Worked 20 total hours.
24 hours and
Made $196.
made $196. And we're looking for,
How many hours he worked at the bookstore?
right, so now we can define two variables. We're looking for number of hours worked at specifically the bookstore, but also for both. What do we want to call these two variables? Sure. So D would represent what? What about the donut shop? How many hours worked at the donut shop? I'm shortening. And then B would represent number of hours worked at the bookstore. I just took out all the variables. No, all the, what? And vowels, there we go. I was like, it was a V word, but I mixed, anyway. Alright, we have 4 numbers. How would we set up these equations? We have totals. We know it's going to equal those. Which numbers will we put together to equal one total?
1025 plus 75 equals 496.
Money goes together. The amount he made at one job, the amount he made at another job, equals the total amount he made altogether. Money goes together. But then how would we set up the other one?
E plus B equals 20.
E plus B equals 20. Right? This would be a good substitution. We could do elimination or graphics. I'll let you guys choose. Of those three methods, which do we want to see? Substitution. Alright, remember that you guys do need to know how to do elimination, even if substitution is your go-to. Right? Because we are looking for a number of hours at the bookstore, if we solve for the donut shop, when we go to substitute in, all the D's will disappear. So get rid of B. First. And then take that, substitute it back into the other one. And when we do that, there's just B's left. What is that 1025 times 20? And if we combine our like terms, what would that be? What would that be when we combine those two? Negative what?
Negative 2.
And some change, I think.
Negative 1.5.
So when we start to solve and we get rid of 205, we end up with negatives on both sides. And what would be the which is one of our options. If we were just writing this, this would be 6 hours. So we know which direction we're going. We're going to do at least one more and see where we are time-wise. Do you have any questions so far? I know this is not the most exciting thing, but it will help you do word problems more confidently and a little bit better, hopefully. Alright, for the one at the top, at the gym, Kara Short. burns 12 calories per minute on the elliptical and 10 calories per minute on the treadmill. If she worked out for 1 hour and burned 666 calories, how many minutes did she spend on the elliptical? What's important here?
Burns 12 calories per minute on the elliptical.
Okay.
10 calories per minute on the treadmill.
Okay. Anything else?
Worked out for 1 hour and burned 676.
Calories. And we're looking for
How many minutes did she spend on the elliptical?
right, so we need two variables. What do we want to call them?
E and T.
Okay. You can use T, but I would make it look a little different or make it a capital T. That way you don't confuse it with a plus. I'm going to make it a capital T. And these would represent what?
Counts on the elliptical and counts on the treadmill.
What on the elliptical? What on the treadmill?
Hours.
Did she work out for more than 1 hour?
Number of calories.
So number of minutes on each. Because we know the amount of calories she burned on each, but we don't know the number of minutes on each. Another one where we're given 4 numbers, how would we set these two equations up? Plus, I'm sorry, I mixed it up. 12e plus 10t equals 676. The calories go together. Because this is number of calories, so number of calories go together. How would we set up the other one? Not quite. So our variables are measured in minutes.
Oh, 60.
So 60. That would be something you would have to kind of know. It wouldn't tell you to do that. Alright, do we want to solve this by substitution, elimination, or graphing?
Elimination.
Elimination, okay. If we wanted to eliminate, we need to solve for E, so we can eliminate T by just multiplying this bottom equation for T. Multiplying by 10 is what it is. And then I'm going to rewrite both just so that they're on top of one another. You have common coefficients for T. How would we eliminate? Subtract. We have 2e. Those would cancel, make 0. And 76. So when we divide both sides by 2, the number of minutes spent on the elliptical was
308.
double check that. 30? 38. 38 what? Yes. Because of the direction the maze is going, the one that we're on, there's only one answer, so we already know what the answer would be. If later you want to go back and solve that one, you're more than welcome to do that. I feel like we did a lot today. So we'll stop with that one, and next class we will start with this, so don't lose that. But I'll give you the remaining time to either keep practicing, start on this self math until Friday, keep working on other missing self math, but don't grab your phones just yet.